This conference will now be recorded.
Okay, welcome everybody. My name's Rich Marriott. I am the chair of the Nautical Institute of British Columbia. Today is our first of a series of technical seminars that we're going to be running from the branch. We plan to run a technical seminar every Thursday of the month through the year. The first technical seminar this evening, Ice Pilotage, what is required to work in the Arctic, presented by Captain Duke Snider, will be followed by Sean Poole on March 17th, the Seaspan and Seaways Global ASD tugs and propulsion systems. March 17th is St. Patty's Day, so make sure you wear green. And then Ryan Andresen will be speaking in April as we lead up to our conference in May 11th to 13th, Maritime Arctic, Changing Opportunities and Challenges. And that will be in Victoria. Please go to our website at www.nautinst.ca for all the details, registration for the conference. As we move into May, we will be going away from these go-to-meeting style technical seminars and going back to a face-to-face technical seminar with a social following it. This evening, Captain Snider is going to be talking about what is required to work in the Arctic. It'll be about a 20 to 30 minute presentation, followed by questions. And then if you wish to stay afterwards for a online social. If there's any questions, please hold them till the end of the presentation, or you can add them in the comment section on the side. Without further ado, I'll present Captain Duke Snider. Duke is a master mariner with 40 years at sea, operating many vessels in a broad variety of ice regimes in Arctic and Antarctic polar regions, the Baltic, Great Lakes, and Eastern North American waters. He has served aboard the naval, commercial, and Coast Guard vessels. He retired in the Coast Guard service as Regional Director of Fleet in 2013 and currently runs his own company, Martech Polar. So without further ado, I'll throw it to Captain Snider.
Thanks very much, Rich, and thanks for everybody who's taken the time to come in this evening. This is more about being social than being a hardcore training session. I'm looking forward to being the guinea pig on the Nautical Institute British Columbia branch's series of seminars, something that we want to do for outreach. This is going to be hopefully a fun and a little bit of educational thing. I see by the attendees that there's quite a few people here that already know me, and that introduction that Rich gave is nothing new. But what I had done when I started this was with an expectation of there being folks that didn't know me to start off with a little bit of background, and Rich has given most of it. Why I've got the special chops, if you will, to present on this topic is that background that I've got outside of Coast Guard, where I've been working since the mid-1990s on ice navigator standards, first with Canadian Coast Guard Transport Canada, when I was contracted in, when I was working outside the Coast Guard, to be the lead author on the initial Ice Navigator Standard project in 1994-95. And that developed into what became the various guidelines for ships operating in the Arctic and the Antarctic for IMO, into the Canadian Arctic Shipping Pollution Prevention Regulations and various other formats. When PC came along, the Polar Code came along, I was the Nautical Institute subject matter expert and delegate on all matters related to the Polar Code and continue in that role with anything that comes up with IMO. As a past president of the Nautical Institute, I got that global reach. So that's sort of what brings me to why I'm talking about ice and working in the Arctic. I want to give a little bit of an introduction to what Martech Polar is, and then we're going to go into a very, very brief overlay of the regulatory environment and getting into what I think is the meat of tonight's presentation, is to talk about certification experience requirements, and then briefly go over some of the voyage planning and execution methodologies and processes, and how it's a little bit different in the Arctic and the Antarctic, and then some very, very basic ship handling. Those folks that are in the audience that are well versed at this, they'll be smiling to themselves as this is all old hat. But I'm going to take it down to a basic introduction. So Martech Polar is a privately owned company. It's based here in Victoria, and we have a unique global footprint. We have an international team around the globe of very, very qualified master mariners who possess Polar Code Advanced Certificates of Proficiency, Nautical Institute Ice Navigator Level 2 certificates, and many years ice experience. The team comes from Canada, Great Britain, Sweden, Finland, Germany, Italy, New Zealand, Australia, to name a few. So that global footprint and experience pool of ice navigators allows us to respond to client needs in either of the polar regions. And we do focus on polar operations now. We leave Baltic and East Coast of Canada to other groups because we're taking our time to focus on the heavier ice that's more likely to be encountered in the polar regions. Besides putting ice navigators on board ships for the voyages, we also provide consulting, subject matter expert and expert witness services in insurance and court cases relating to ice damage or ship damage. We do voyage mission planning for new operators. And another area that takes a fair amount of our time is actual completion of Polar Code operational assessments for new ships and the writing or verification of Polar Waters Operations Manual. So we are busy 12 months of the year. We have an Arctic season and we have an Antarctic season, and in between we're doing consulting work. When we look at that team, I'm pretty proud of the group that we brought together, and some of you guys are in the audience tonight. These are all people that come together with a very, very similar ethos about operating an ice. And we don't go out there to ensure that the ship gets to the port. We go out there to ensure that the ship doesn't get dented, doesn't get damaged. Getting to the port is the least of our worries. Our job is to keep the ship, the personnel in it, and the cargo safe. So that is how we operate. If the ice becomes too onerous, it's stop and turn around. And that's a basic rule of thumb for us. How do we get there? Well, we have to look at that regulatory environment. And the biggest piece since 2016, of course, has been the Polar Code. I could go on for a 2-hour presentation on the history of how the Polar Code got to be where it is today. But for us tonight, we have to understand that this is an overarching IMO code that is the first mandatory code covering ships operating in polar waters as defined within the code. Interestingly, the Polar Code is not a standalone instrument. It has to be enabled, and it is empowered by amendments to SOLAS, STCL, and MARPOL. Without those three primary IMO instruments, the Polar Code would have no force. But once they mention SOLAS, the pieces about ship construction, STCW about training and certification, and MARPOL about pollution prevention, they say polar ships must be polar certified, must comply. So you have to jump a little around when you're looking at it. It's not simply getting a copy of the Polar Code and saying, I've done this. You have to make sure you reference the enabling amendments to SOLAS, STCW, and MARPOL. In general, the Polar Code is about the construction, the operation, and the crewing of ships for polar operations. It's not necessarily about ice, it's about polar waters. We'll get to how that's a different differentiation that's important to us as bridge mariners in a few minutes. The Polar Code requires national states and coastal states to enact regulations that put force within their own structures, basing them to the requirement that is around the ship construction. And it starts with the issuance of a polar ship certificate by the various flag states, classification states, to the ships, confirming that that particular ship meets Polar Code requirements, as well as the classification and national requirements. It identifies a ship category of A, B, or C. This very simply breaks the ships down into ships that are not going to be in ice, ships that are going to be in some ice, and ships that are going to be in heavy ice. Specific definitions have to be adhered to, but as a generality, that's what we're looking at. Most ships will likely fall eventually into the category B, those that are going to encounter certain amounts of ice, though at present we're seeing most operators trying to have their ships categorized as types or category C, which is a no ice situation. We're going to be talking about ice, so move forward, forget about the ABC for the time being. The other piece, and I think the most important piece in the end of the Polar Code, is it requires the ships to have polar waters operations manuals. In essence, a PWOM is a polar-focused safety management manual. And in fact, the Polar Code makes it clear that PWOMs are in addition to the safety management system. And if there are elements that are required by the Polar Code to be in the ship's PWOM that are already outlined in the existing safety management system, they don't have to be rewritten into the new PWOM. The PWOM can refer to the ship's preceding safety management system. But the next layer that we always have to consider, and the folks on my team that are here now are quite familiar with this, is the Polar Code's one thing, but we always have to look at the coastal state regulations that are around it. We are very familiar in Canada with the Arctic Shipping Safety and Pollution Prevention Regulations, which are the newest regulations in Canada that encapsulate Canada's interpretation of the Polar Code for its flag state ships and for ships operating in Canadian waters. Denmark over Greenland, United States, Russia, and Norway over Svalbard have their own national regulations and enabling regulations that put the Polar Code in effect in their waters. The Russian regulations are by far the most complex, based around the Northern Sea Route Administration. So what this page is telling the uninitiated is the Polar Code isn't everything. You have to go the next level. You have to go directly to the national regulations as well. Now into certification and experience. The very first step here is to understand that the Polar Code has a requirement for bridge watchkeeping officers, chief officers, and masters to have specific training and certification. The requirements are based on a ship type and the extent of ice. And if you look at this table across the top, you have tanker, passenger, and other. Tanker and passenger are considered the two highest risk vessels, or the ones with the greatest consequence of negative effect if something goes wrong. They have the highest requirements for training. The ice conditions are broken down into ice-free, which means no ice at all, open water, which is conditions less than 1/10, and then above open water, which is any ice concentration greater than 1/10. One of the angles that's been sort of playing back and forth lately is that there is some interpretation, say in the coast of Greenland, that is encumbered by bergy water, that it's not sea ice and therefore does not count as open water or above open water, that it counts as ice-free. We are moving forward with a more restrictive interpretation that anything that has more than 1/10, whether it's glacial ice or sea ice, should be counted in the open water or above open water. And if you have questions how that works out, we can come to it at the end of it all. The big piece in the end of the section on the training and the certification requirement, whether they have basic or advanced, allows for ship operators or ships where their crew are not in polar waters at a high enough frequency or often enough to accumulate the skills or the sea time. Additional certified crew can be brought on. And that's where Martech Polar comes into the picture. If a company doesn't have the full requisite of all their bridge officers, their master, their chief, with the advanced or the basic training required under the Polar Code, they bring on an additional officer in the way of an ice navigator who should be signed on to the ship, must meet all the requirements that a normal ship's officer would, but they're an addition. So what do you have to do to get these various levels? Well, when we look at the two levels, they're fairly clearly laid out in syllabi under the model courses, and it starts at a basic level. The basic level is a course of about 5 days in duration. An individual with junior certificate, a junior bridge watchkeeping officer, or anyone wishing to go into the polar waters eventually must start with a basic. They must complete a course that is flag state approved. They must convert their training certificate into a certificate of proficiency, which is flag state approved. And then they can stand a watch as a junior officer or as a senior officer on ships that allow the master or the chief officer to sail with only a basic. In order to get the advance, which is required on passenger ships and tankers and in heavy ice, an individual must have been operating with the basic certificate of proficiency, have accumulated 2 months of sea time in polar waters, then gone back to school for the advanced course of roughly 4 to 5 days, obtain a new certificate of proficiency in advanced training. Both courses or both certificates are valid for 5 years, and in order to revalidate, you must prove 2 months sea time in polar waters in the last 5 years. What we've been finding, though, since 2016, that simply having training at the polar waters level and even meeting the syllabus as put down in the IMO model courses, officers aren't necessarily being exposed to ice operation. All that you're required to have in sea time to get an advanced polar code certificate of proficiency is sea time in polar waters. You don't have to see any ice. So one could come out with an advanced certificate of proficiency and suddenly be thrown onto a ship that's going through ice and never having seen it before. That's what we're experiencing in the last couple of years, ships coming into Canada with officers that think they know what they're doing, but they don't. So that brings us to another package. When the Polar Code was finally put in place, it became apparent to an awful lot of the more experienced operators out there that the certification program did not meet their full needs. It did not prove or ensure that bridge officers had competence in ice. The Nautical Institute was approached by a group of insurers and ship operators and was lobbied to carry on with their development work to complete and set up the Nautical Institute Ice Navigator Scheme. Where we are today is we have a scheme in the Nautical Institute that complements the Polar Code, where we have basic and advanced courses in polar code training. The Nautical Institute has level 1 and level 2. The syllabi are very similar between a polar code basic and a level 1, and a polar code advanced and a level 2. However, the Nautical Institute approved courses have some additional elements that focus on operating in ice. The simulations are much more specified to be approved for Nautical Institute. The other piece about the Nautical Institute Ice Navigator, it is not focused purely on polar waters. It is a global coverage about ice experience and ice capability, not necessarily polar. So why is it necessary? Well, part of what I said, the lobbying group that came to the Nautical Institute gave us that push. But we have seen since 2016 that polar waters training and certification is not universal. There are some flag states that are not as familiar with operating in the Arctic or the Antarctic, who have taken the lesser onerous route and approved local training courses that really aren't up to the standard that was envisioned. Persons are coming out having attended courses that may indicate that they are flag state approved, but the quality is not there. We're seeing mariners who have training certificates, but they don't have flag state issued certificates of competency or certificates of proficiency. We also see that mariners can have PC training and certification, but as I said, lack the rudimentary competence in ice navigation. The Nautical Institute Ice Navigator complements that and adds that ice experience. That's why every Martech Polar Ice Navigator has both the Polar Waters Certificate of Proficiency in Advanced and the Ice Navigator Level 2. I throw this up just really to show you how in-depth the pathways are for the Nautical Institute. On the left, the basic, and on the right, the advanced, showing some of the specifics of what's there. If we describe now, it's fairly simple. For a level 1, a junior officer or a cadet can go through and completes the level 1 basic course. They must have a certain amount of practical at-sea experience in ice or approved simulator experience. And these are more clearly defined in the standards, and I won't get into the detail. They must have an STCW or equivalent certificate of competency. Through part of the Ice Navigator scheme, the Nautical Institute has examined applications from various certification bodies that are not necessarily STCW. And as an example, we could say the United States Coast Guard. The United States Coast Guard, they have bridge navigation qualifications, and the equivalencies have been built up so that a U.S. Coast Guard officer with a U.S. Coast Guard specific license can still obtain a Nautical Institute level 1 or level 2, but their ice navigator would be restricted to the limitations on their license. If one has an STCW license, the restrictions are almost zero because it's a global foreign going thing. But it is possible that a home trade type certificate or coastal certificate, non-STCW, could be accepted by the Nautical Institute, but it will limit the ice navigator to the limits of that certificate. So if the individual, for example, is inland waters only, their Nautical Institute ice navigator will only be acceptable with that certificate. They couldn't use it on international trade. And the level 2, that's where we really get into the meat of it. You cannot get a level 2 until you have held your level 1 certificate for a minute and gained a minimum of 50 days active bridge time or master time. And of those 50 days, 30 days must be in ice conditions that are acceptable to the code. Once you've got that, you go back to school, do the advanced level 2 course, and you come out and you have a certificate as an ice navigator level 2. Revalidation for both is the same, or they revalidate every 5 years. The 5 years was chosen to match with SGCW requirements, and 30 days in ice must be proven in order to maintain the qualifications at either level. So some more of the information, I'll leave this one up for a minute, can be found either with an email to icenavigation@nautinst.org, or to going to the 2 sites that you see here. The first one is the full accreditation standard. It's the document that lines out exactly what the training modules are, what a school has to do to qualify to be included as a Nautical Institute Ice Navigation Center. The second one website you see here goes more into the certification process. It's best to have a look at both sites to get an idea of how it all comes together. The vast majority of the people that we've got in Martech Polar all obtained their Nautical Institute Ice Navigations under the grandfathering scheme, which is no longer active. The grandfathering allowed for personnel in the industry who could prove a higher level of experience in the ice over the last 10 years, that they already had the requirements. The certification group at Nautical Institute headquarters would take the applications, review them, and would issue the appropriate certificates. We are now in a position with the Nautical Institute that we're no longer doing wholesale grandfathering, but we're requiring people to come in with the new entry levels at either the basic or the advanced. Details are on these sites. I will say that one of the weak points we have at the present time in the Nautical Institute is that there are only 2 fully accredited or authorized training centers for the Nautical Institute system. The Marine Institute in St. John's, Newfoundland, and the Makarov State Maritime Academy in St. Petersburg. The training center in Odessa in the Ukraine was certified, but for some reasons, some political, in the last little while, they have not re-qualified. We, being the NI ICE group, are dealing or working with 4 other schools right now to ensure they meet the standards and they can become accepted as training centers. So that's the sort of the basics, of very, very basics of what you need to operate. If you're going to go into the polar regions, into the Arctic, the first thing you're going to have is the Polar Water Certificate of Proficiency, either basic or advanced. If you really want to make a business out of working in the Arctic or the Antarctic, or for that matter, anywhere in ice, you also really have to consider taking the time and applying for and receiving your Nautical Institute Ice Navigator certification. Now, once you've got all of this, you want to play a little bit with the voyage planning. Again, I'm talking to the converted, or preaching to the converted here. When I look at who's in the room, you guys know this stuff inside and out. But again, an introduction that I know the NI is going to use this a recording for others around the globe that couldn't call in tonight. So when we look at voyage planning execution, the one thing we have to remember, the polar regions are quite different. They are like no other. The advanced planning takes on a whole series of new and additional challenges. One of the basic ones is you have to plan for variability. It's not just whether the weather is a problem, it's ice. Ice can be encountered, ice can cause a major deviation, ice can end your voyage in a heartbeat. You've got to plan for self-sufficiency in the polar regions. You may be in the northern sea route of Russia and reasonably close to the northern shore of Russia, or you may be in the archipelago of Canada, but you are further from help in those areas than you are often in the North Pacific or the North Atlantic on Great Circle routes. And the Polar Code recognizes that. In fact, the Polar Code makes it clear that ships must be prepared to deal with self-survival for 5 days before rescue comes to them. And that's something that has to be taken into consideration with the overall planning. The other piece is you have to plan for a polar voyage incorporating more drastic delays and potential voyage termination. I was on the phone for several hours today with a client who runs a number of very large cruise ships. And one of the things that they're doing is that they prepare for the post-COVID resurgence of polar voyages is ensuring that a lesser number of their ships are polar certified, but that more importantly, they are reassessing their whole voyage planning process to put in place reductions in overall planning speed. And as was laid out to me by the marketing people in this discussion today, this company is used to having speed of advance at 20 knots and maybe slowing down to 14 knots. Now what they're doing is they're recognizing that those speeds are simply not acceptable in any of the regions where ice may be encountered. And they're essentially dropping their planning speeds from that 20 knots down to 14, 12, and 10, and then even slower. And that to me is worth its weight in gold. It recognizes that we're not in the same place as we are in the rest of the world. It's not just avoiding a storm. It's slowing down for thick fog when any possibility of ice might occur. So we all know that preparation and effective voyage planning is key, but you have to pull in these other pieces. And as you're looking at this, the first thing you're going to look at is this a polar voyage? Does the vessel actually go into the waters defined as polar code waters, or does it skirt them? How do the polar code requirements prevail over the ship with respect to planning and preparation, which are clearly identified in the polar code and should be further identified in the PWOM, the Polar Waters Operation Manual? You must ensure that the crew have the necessary experience. If you're going to be encountering ice, if you fall into the appropriate category, you're going to have enough watchkeepers on the bridge with the appropriate polar code training to cover 24-hour operation. One person with certification is not going to work anymore. Hours of rest work just as much on polar code certifications as not. That's why some companies may have one or two of their officers with junior basic level polar code training, but they're opting to bring on senior, highly qualified ice navigators to fill that gap. It fills the gap for polar code, but it also gives the bridge officers breathing space. 2 additional ice navigators on a cruise ship of 3,000 passengers gives the rest of the officers time to do what they need to do on a daily basis, but the focus can be on the ice avoidance and the protection of the ship. That's why we talk about reaching out to specialists, get the real advice, talk to the people that are out there, whether it's another shipping company that has very solid experience, and I use the example as FedNav in Canada, over 50 years of very solid polar experience, or going to companies like our own here, Martech Polar. When we get into the planning, it's like anything else. There's long-range strategic, where you're going to look at the geographic and climatological considerations. What seasons can your ship actually operate within polar waters, within its restrictions for its ice class or lack of ice class? You can't just say, I've got a polar ship certificate, I'm going to go into the Arctic. The bottom line is, for 9 months of the year, there's ice everywhere. The short range planning, we all know in any voyage planning course that talks about the tactical. When we're dealing with ice, tactical plans must be even more flexible, because you are moving not just to avoid the navigational concerns of hard water and bottoms that are closer to the surface than your hull depth allows. You have to deal with the potential of moving about to deal with the ice. The ice environment is constantly changing. In the Arctic, We are affected by the Arctic polar pack, which still has multi-year ice, regardless of the popular press that talks about ice-free years are imminent and that sort of thing, and there is much less multi-year ice. Yes, that is true. I mean, we see it very clearly as we operate up there. The global climate change is making profound effects. But one of the interesting results of less overall multi-year ice is what's there is able to move into areas where it hadn't been seen before. So where big ice bridges would hold the polar pack back from coming into the Canadian archipelago in the past, those don't exist anymore. So multi-year ice is creeping further south, and because of its nature, it's thicker, it's harder, it can move down and it doesn't melt out the same as first year ice. So we're encountering that ice where you wouldn't have in the past. The other piece is we can't assume that because 2021 was potentially a good year, that 2022 will be. Years vary dramatically. And those of us that have been going up there for the last decades can recount good years and bad years. We look at 2018 as one of the bad years, locking up the central Canadian Arctic. A lot of Arctic communities in Canada didn't get resupplied as they normally would because of heavy ice. Years before that, low ice class ships could come through the Arctic in a Northwest Passage quite reasonably easily, but that's not necessarily the case. Last year, heavy ice sat very close to the coast of Alaska for quite some time, which made it difficult for ships to get by, but they were able to, but not as easily. The bottom line is the area remains ice covered for 8 to 9 months of the year. When we're looking at the regions up there, there are areas where the ice tends to bottleneck and choke up. These are typical of the Northwest Passage. Year to year, these are what the ice navigators will be watching for. Simpson Strait is circled in green because it is the one passage that will be ice-free year to year. However, it is draft limited to approximately 7 meters. So the one route that you could most easily get through tends to be beyond the capability of the larger ships that might want to come through. Similar effects, ice choke points consisted in the Russian Northern Sea route, and you can see that they're in the areas with the channels between the various islands, and Novaya Zemlya chain, Severnaya Zemlya, Novosibirsky Ostrovo, and the Wrangel Island chain. That's where ice can linger and it can block off shipping. So this is the kind of stuff that you want to be looking at. And finally, when you're planning, we have to understand that not everybody is going through the Northwest Passage. It is not becoming a highway across the north, nor is the Northern Sea route. Why is it still restricted to the usual players or the one-off expeditionary vessels? Well, it's because it is remote. In the Northwest Passage, it's only small villages. There are no fuel resupply or repair facilities between Nuuk and Greenland and Dutch Harbor in the Aleutians. So when you go into the Northwest Passage, you've got to be prepared for the entire voyage without a resupply or a repair. It's somewhat similar in the Northern Sea route. However, in Russia, there are higher densities, and in some of their mineral extraction cities, as they are, they can have populations up to 10,000. But we see that the biggest amount of development in the Northern Sea route is really west from Norway to that Novaya Zemlya, in the core area for the hydrocarbon resource extraction, oil and gas, Yamal, names that we've heard. The whole Russian ethic about providing icebreakers in the Northern Sea route is not necessarily to provide for support to a highway across the Arctic. It's there to ensure the export of their natural resources, their only international income. So you can see why that Russian ethos about building icebreakers, building these ships, it's about a financial survival of Russia. It's not about a military takeover of the world. It's what they need to survive financially in the world. They have a heavy commitment to provide icebreakers, and they have been building and renewing. But to go through that, you've got to understand it's a massive, complex bureaucracy. And one doesn't normally say, oh, I'm going to go through the Northwest Passage and apply. You need to be looking at it well in advance and doing the Russian foot dance to get the appropriate papers and approvals. Emergency support is limited. Russia has aggressively been building SAR infrastructure over the last 15 years, again, predominantly in support of their requirement to export large quantities of gas and oil. There is no similar effort being made along the Arctic coastal states, United States, Canada, Norway, or Greenland. The United States Coast Guard does an annual Operation Arctic Shield, which prepositions a single helicopter in Kotzebue and puts one of their black hull buoy tenders into the Arctic, and lately one of their new national security cutters. But the national security cutter is not ice capable, and the American Black 225s are light ice capable. Canada does have a robust Coast Guard presence. We're very proud of that. Our ships are getting old, but Canada does nothing to preposition any air assets into the Arctic. All the air assets must come from southern bases, whether it's Trenton in Ontario or even out here in Comox. So a fixed wing aircraft can be 12 to 18 hours away from an incident, and a rotor wing can be even further. The Antarctic, I put this up, there is no in-position search and rescue. Their search and rescue facilities are totally land focused on the researchers. They have virtually no capability to reach out over sea for any search and rescue. When you're doing your planning and you're thinking of going into any one of these areas, all three are the same. There are shipping corridors that have been reasonably well surveyed to modern standards, but going outside of those corridors to specific areas or through specific areas is incredibly risky. Outside of those corridors, in all three, Northwest Passage, NSR, and the Antarctic, you'll come across only sporadic or trackline soundings. We still are having problems with adjoining charts with different datums, but as we move forward and the paper chart projections are being replaced by ENC, we're getting to a point where the datums are being evened out. But still, it is always incumbent upon the navigator to ensure that even their electronic chart is tuned and you're understanding what datum it is. If you're transferring onto a paper chart for any reason or using a paper chart in a gap, you have to make sure there's that datum differential being done. Those of you that are experienced know what I'm talking about, and I'm not going to bore you anymore with that. The icebreakers, we hear a lot about that. You know, the so-called icebreaker gap, and people will go around and say, oh, Russia has 40 icebreakers and the United States has 2. Well, Russia doesn't have 40 icebreakers in the polar regions, and the US Coast Guard doesn't just have 2 icebreakers. If we compared all of the Russian icebreakers, the light harbor tugs and the port icebreakers that are actually roll up into their 40-odd icebreakers for the nation, we also have to include that the US Coast Guard has 2 polar icebreakers. They've got all of their 225s, which are light icebreaking capable, and a fleet of very capable icebreaking tugs. But when the pundits and the popular press get out there, they just say, oh, it's 40 to 60 Russians, Canada or United States only has 2. The other reason Russia has more icebreakers is because they actually have shipping going in and out of their ports along their massive coastline. United States, their resupply of their Alaska communities doesn't have to depend on icebreaking. The ice pulls right off the Alaska coast, and the resupply occurs in essentially ice-free water. Canada, on the other hand, has a more robust icebreaking fleet because, of course, we have ships that must work the ice to resupply communities. we've heard from the Canadian Coast Guard in the last year that, oh, we're committing 8 icebreakers. But generally speaking, the in operational area number is no more than 6. They may have 8 different ships assigned during a navigational season, but what we see are 6 at any given time, up to 6 at any given time. The saddest part of all with this one is, from my opinion, is that the delivery of the single polar icebreaker that was ordered when I was still in the Coast Guard it's somewhere out there, but they haven't started cutting steel. The other piece that I'm going to talk about here is the gap in communication. Most operators get quite comfortable with the high broadband capability of VSAT and Inmarsat. And if you look at these two pictographs, you'll see that the gaps are right over where you need to be. When you look at the Canadian Arctic, that's all Canadian Arctic. It's a gap. The Russian Arctic through the center is a gap. There's no coverage. We do have Iridium Next, the low Earth satellite or low Earth orbit satellites. They do have full coverage over the poles, but the bandwidth is much narrower and they're much slower. So you lose broadband capability. Oftentimes GMDSS, Satellite C, or HF are your only fallback. And the final piece, though not as important to the bridge way of thinking, but just to put it in the back of your mind, is as soon as a ship enters any of these red areas, their insurance rates go through the roof. So you can see that virtually all the Arctic, except for a narrow band up to Svalbard through that little peak right in here, it's all about coverage, insurance coverage. So what you make up in short distance and fuel, you're going to end up paying insurance. Very quickly, some of the rules for working in the ice, and this is assuming that we're operating a low ice class. The operation of a low or non-ice class vessel versus high ice class is radically different. It's comparing a ship with a tin can hull as opposed to a ship with 2 inches of steel. You really have to understand the difference. And we found that sometimes folks that have a long history of operating in big, powerful icebreakers, they don't transfer very well onto thin-skinned polar class 7 or less ships. They don't understand the risk they've got. You as an officer on a new ship going in, be aware of what your ice class is. You are not an icebreaker. You are an ice strengthened, whether it's passenger, cargo, or whatever. Ice-breaking ships are highly maneuverable, massive hulls, frame spacing tighter. They're able to escort and provide ice management, huge power, and a hull form that's specifically designed to enable them to conduct aggressive operations in ice. Quite different from taking a ship that normally carries a cargo of either people or whatever and making it a little thicker steel with a little closer frame spacing and adding other bits and pieces. So the skills between operating the two are quite different. Basic rules. This one, and the very first one, is if you can avoid ice, you do. But don't take this to mean that avoid it at all costs. Sometimes there are situations with a modern ice class ship that entering the ice is to your advantage within the safety realm. I've been doing a number of insurance arbitrations, and one lately, the charterer was claiming the master made an improper decision by taking his ship into ice instead of going an alternate ice-free route. The decision point on that particular case was, had the captain gone to the north of a series of islands, he would have been hit by storm force winds with 10-meter seas, horrendous weather conditions. He stayed the south of the islands in less than 3/10 ice. Unfortunately, something else happened and they damaged the propeller. But it was not because of the decision to enter the ice in the first place as opposed to avoiding ice. So when I give that first, if you can avoid ice, do so. Also be aware that avoiding ice isn't a must if you have the right conditions. Generally, when you're in the ice, keep moving, if slowly. Once you stop, you run the risk of simply getting stuck. Work with the ice, not against it. Ice moves. Sea ice generally moves under the effect of wind, where glacial ice, the Bergy bits and icebergs will move more to current. They'll move against each other. So be aware of what the ice is doing, and don't get yourself caught on an ice lee shore. The biggest piece of all, excessive speed leads to damage. Always slow down. Always slow down. Know how your ship maneuvers so that you can maneuver it safely within an ice field. And remember that Arctic ice is not the same as first-year ice encountered in the St. Lawrence, in the Great Lakes, or in the Baltic. There is heavy multi-year, much more dense, much more damaging, heavy glacial ice. A growler of glacial ice can be the size of a Chevy pickup truck and do more damage than a 30-meter first-year ice flow to a ship, because the density of that ice. When you're coming towards ice, rule number one, always slow down, have everybody on standby, yada, 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 your engine room on standby, your lookouts up there, approach the ice in a perpendicular, if at all possible. Enter very, very slowly, adjusting speed so you can stop in the distance you see. And once you're in the ice, then you start to slowly bring your speed up to a comfortable speed, looking always for open water leads and lighter ice patches. And if you don't know how to find them, that's why you hire an ice navigator. Try to do your turns in open water or thin ice. If you must turn, keep in mind the rudder, dramatic rudder movements may slow or stop the ship when you don't want to. If you have to back in ice, it should be avoided. But if you have to, a simple 1 to 2 minute burst of ahead to clear the stern out, and then backing up sequentially, bursting ahead and astern to ensure that the sternway is open of ice, and always ensure your rudder is amidship before you're backing up. Final piece on the page, always look for signs of pressure. If the pressure is building up, you want to get out of that area as quickly as you can. Ramming, and I only include this one to get it out to folks that the vast majority of ice class ships are not built for ramming, and it should not be done. If it gets to a point where you're in a vessel, you think that ramming has to occur, you should be out of there, or you should have been requesting icebreaker assistance long before. With the higher ice class ships that we're now seeing coming out, Ponant's PC2 class passenger vessel, it's got a higher ice class than any Canadian Coast Guard icebreaker right now. It can ram ice. So in closing all of this, excessive speed is a major cause of ice damage. Always run slower. Always make sure you have qualified and experienced people on board, and do your planning. And with that, one of the things that I would like to bring up is to reiterate what our branch chair, Captain Rich Marriott, explained or brought up in the introduction, that just in a couple of months, we're going to be having a globally interesting maritime Arctic conference. I hardly recommend anyone interested look this up. It is one of the premier Nautical Institute 50th anniversary events. So it's going to have a gala dinner. We've got over 50 speakers over the 2 days, covering much of what one would ever think of finding is interesting in the changing challenges and opportunities. And with that, I'll leave it off to a period of questions and stop sharing my screen if you're okay with that, Rich.
Yeah, that's fantastic. Thanks, Duke. Appreciate it. We'll open up to questions. If you don't feel comfortable talking, please put it in the chat. Okay, I'll start off. I have a couple of generic questions, Duke. Is there a Nautical Institute Ice Navigator logbook?
There is not an Ice Navigator logbook at present. However, there are templates that the Nautical Institute can make available for that. It's one of the pieces that had been in the planning, and then COVID hit, and it became very, very low priority. So if anyone is interested, I can certainly provide the templates that our company uses, which are fully compliant with Nautical Institute requirements. And they are, in fact, essentially what was required under the old Transport Canada's Arctic ice regime shipping system voyage reports at the end of a voyage, which show the details of the ship you're on and courses steered and that you've actually been maneuvering and the type of ice. But I can provide that to anyone that pops me an email at any time.
Okay. Anybody else with a question?
Yeah, I had one for you there, Duke. Someone who's operated in the Arctic on an icebreaker and stuff, but still doesn't have the basic training. Trying to get the training through Memorial, especially with COVID, they haven't been offering it much. Can you just confirm if that's still the only place, and or if more training is offered, both if that's in the works or something that's aware of, with the polar code, especially with people who don't have the training right now?
Mhm.
It can't be grandfathered.
The Marine Institute is not the only Canadian institution that has a polar code capable or a polar code approved course. Rimouski has one, and there is a group that's trying to put together a basic course for Western Marine to meet just for the basic level. They're not doing advanced. But what I can, I think, hopefully give you a little more positive is that the Marine Institute is doing more polar code courses fully or not fully in a very virtual environment. And they've been able to put together as much as they can in a virtual course. But because of the requirement for full mission simulation, there is still a requirement for a student to show up at a training institution. As COVID goes behind us in the next weeks, I think we're going to see a resurgence for this, where the courses are going to come back online, more easily obtained. There are 3 institutes in the United States that do U.S. Coast Guard polar code accepted courses. But I'm not sure to what level Transport Canada is accepting them on a Canadian certificate of proficiency.
Okay, yeah, thanks. That's helpful. I just know it's something I've been looking at for a while, and just trying to find someone that offers it where you can fit it in with the schedule has proven challenging.
Captain Dockrell, I think you have a question.
Call me Simon, Rich. Hi, everyone. Thanks. Yeah, this is very interesting, Duke. Appreciate that. It's the first one of these that I've been to, just a recent member. So I'm looking forward to coming to some more. I did have a question along the Ice Navigator under the Arctic Shipping Pollution Prevention Regulations. So the old Ice Navigator understanding. How does that fit into the whole thing in your mind's eye there?
Well, an Ice Navigator, as defined under the old CASPR, was quite clear. You had to have 50 days of experience in Arctic ice in Canada within the last 5 years. That came out of the new regulations. It is no longer part of the regulations. All the Canadian regulations point to is the Polar Code Basic and the Polar Code Advanced. However, since the new act or the new regulations have come into force, Transport Canada has been noticing some issues, and various operators have been bringing those issues up to them. And we know that Transport Canada is in some degree looking at a way to fill a gap that has developed. to maybe put back in place something similar for an ice navigator requirement above and beyond polar code. And of course, from the Nautical Institute's perspective, we're pointing out to them that one of the easiest ways to do that is to say, in Canada, we accept ice navigator level 2 as meeting that statement of requirements. It's being done in other places. And other flag states are now looking at the Nautical Institute certification and saying, well, yeah, you need polar code, but if you're actually going to go into ice, why don't you get this as well? So until Transport Canada fully wakes up and makes their changes, they're in the process of rewriting their whole personnel side of certification regulations. We've been making submissions, we have made submissions to them on some of the shortfalls that we've seen in the present reg structure. But it takes a bureaucratic will to move forward. It's partially there, but like everything else, something like that is the lowest piece on their Christmas list with all the COVID issues that are going on.
Yeah, thanks. Yeah, no, interesting. Good.
And David, you have a question?
Yeah, more of a comment. So thank you, Duke. That was a really good presentation. For those of you that don't know me, I run Western Maritime Institute, and as of tomorrow morning, we're approved to teach the Polar Basic course. But we didn't like what the syllabus was that Transport Canada had, so we're using our simulator, our full mission simulator, to do it. So there's 5 scenarios over the 4 days and a bunch of stuff. I just thought I'd put that out there. And then the plan is by this time next year, we'll have the advanced as well.
Excellent. Good news. I didn't see an application from Western Maritime to be accepted for Nautical Institute approval. How come
I needed to get TC approval first. It'll be the next order of business. And the instructors are Ivan Oxford and Mark Taylor, if anybody is interested.
That's excellent. I know them both. When's the proposed first class scheduled?
We originally were looking at April, but we're probably going to bump it up to March. The problem is our simulator is oversubscribed for everything else that we need to do there. So we're trying to figure out how to do it, even to go to 2 ships a day if we need to. So there's lots of CEN-Os, CEN-Ms, and all that kind of stuff going on too.
Right. Okay.
I want to see your application to the Nautical Institute within 2 months.
Well, I'll see you in Victoria next month.
Okay. We'll have the CEO from London, so we'll both put the pressure on you.
I'll put the squeeze on me. Okay, thanks.
Absolutely.
Any other questions out there? I'll throw out one more just to end it off. How has technology influenced the way that ice navigators work in ice-covered waters? And part 2 of that would be, is there any ice surveillance systems that the ice navigators commonly use nowadays?
Oh, absolutely, 2 fantastic questions. And one of the things I had to do, given the short time, was take out a whole series of slides on technology and what we're seeing changing. In a nutshell, technology is advancing very, very rapidly, and taking a ship into ice 10 years ago is not the same as it is today. Some of the things that we've got now are improvements to radar scanners. We're getting dual polarized radar, which depicts ice much, much better than single horizontal polarized radar. We're getting high-speed scanners that again will show sea ice and glacial ice much better. And on top of the actual scanner systems and wave propagation, the display monitors and the computer manipulation of the returns is getting better, so that you can add on signal processors to a standard marine radar that will make it a little better for working in ice. Other tools that are coming out, much is being said about forward-looking sonars as a future tool. The problem with forward-looking sonars is they're really great picking up deep draft glacial ice or multi-year ice, but they don't have an angle forward enough to pick up a low draft of typical sea ice. So they're a tool in the box. I think the biggest advances that we've seen in the last few years have been the satellite imagery and the capability. It's not just an occasional radar sat image with synthetic aperture radar. There are now several Sentinel synthetic aperture radar satellites with fairly good resolution. In some cases down to less than 5-meter resolution. And the frequency of satellite passes over areas now are much greater. So in the past, you might have been able to get a radar sat image every 2 or 3 days in a specific area as the satellite went around. Well, now we've got radar sats, we've got Sentinel, 2 or 3 Sentinel satellites, and each one of them will come across much more frequently, so you get a really good synthetic aperture picture. We're also getting a better series of satellite image from different types of sensors. The passive microwave sensors that pick up temperature and that sort of thing. Their resolution is not as tight as a synthetic aperture. It's not as accurate, but it gives us an idea. So an experienced ice navigator can take together a synthetic aperture image, a passive measurement, and a visual measurement if there's no cloud, and make a pretty good idea. And the ice centers of the world, they are getting better at artificial intelligence, doing the assessments of the satellite images and producing the ice charts. So last year we saw a huge leap forward when DMI, the Danish Meteorological Institute, began to issue AI produced ice charts from satellite images. A satellite image takes an awful lot of space. You know, it can be hundreds of megabytes to get a good satellite image that's really of good use. So most ships don't have that capability. So they always fall back on ice charts, an ice chart of 200 or 300 kilobytes. So it's imperative that if ships have to take advantage or have to rely on something like an ice chart is produced as quickly as possible and as accurately as possible. And that's what the AI is beginning to do. It's getting us a much better quality ice chart much more quickly. So we're not waiting. Other technology that's out there that I think is going to be very beneficial is the advances in fail-safe hull sensors, as oddly as it may seem. Some of us have been on ships that have been fitted with hull sensors, but we know that they're hit and miss in their accuracy. But the work that's been going ahead could very well get us within the next 2 to 3 years to systems that can be installed on any ship that will give us the sense of where the pressure is on the bridge much more accurately than we've ever had before. And telling us that, okay, the pressure is on this side or on here, and giving us guidance. So, technology like that, there's stuff that's out there that it's above and beyond what most normal conventional ships would have, but it can be had. It just costs money.
That's fantastic. Thanks. Okay. Is there any other questions?
I think it's time for people to tell sea stories.
I think you're right. So just one last reminder, May 11th to 13th, Maritime Arctic, Changing Opportunities and Challenges. It is also the Golden Jubilee of the Nautical Institute HQ in London. So we will have representation from London attending our conference in Victoria. And I hope that everybody here can make it to that conference. I'm going to end the recording, and we can